Welcome to Chapter 17, Enlightenment and Revolution. We're going to be talking about this scientific revolution, the Enlightenment of Europe, its impact, and the colonial Americas and their American Revolution. This is Section 1, talking about the scientific revolution and all of the people involved with the scientific revolution. Alright, the scientific revolution begins with a revolution in astronomy, challenging the ideals of the church on the ideal of the universe. So it's the roots of modern science, and it begins all of their aspects, all of their ideals of thinking and looking at things in a different aspect. So the roots of modern science begin with this scientific revolution and begin with the revolution in astronomy. We had the Ptolemaic system of old. Ptolemaic system told us that the Earth was the center of the universe. The Earth was the center of the universe, such as this picture right here. Okay, so the Earth was the center, and everything else revolved around it, with the Moon, then Mercury, then Venus, and then the Sun on that fourth ring around the Earth. And pretty soon people got to studying this geocentric theory of the universe, looking at the stars, charting all the planets, charting all the stars, noticing that they were not just planets or orbs of light, they were actual substance out there, and it was circling around, and that the Earth was not the center. And this was the heliocentric theory of the universe, where the sun was the center of the universe, developed by the man in the lower right-hand corner, Nicholas Copernicus. Copernicus said that the sun was the center, and although he never challenged the church on this ideal, never challenged the church on the ideas that he had brought forward, he released his book on his deathbed, as I said this morning, on the revolutions of heavenly spheres, and discussed what was going on within the universe and how this universe was developed and what was going on with all of it. Okay. He also had some help and a guy by the name of Johannes Kepler. Johannes Kepler was an understudy of Copernicus, and Kepler studied the laws of planetary motion. And with his work, combined with Copernicus' work, those ideals start to emerge and start to come to the forefront. So a guy by the name of Galileo is the one that brings it forward. Okay, Galileo Galilei was an Italian scientist, was a man of God, and he basically said, I'm not challenging God, I'm challenging the ideals of the church. And he had studied these new theories on astronomy, he had studied with these guys, he had worked with these guys, and knew that it was not correct. So he was willing to stamp up and challenge the church, challenge the ideals that were there. And he's jailed in 1633 by the Pope. He lives in jail for a while. A new Pope comes into power. That Pope is a friend of the family, basically, of Galileo. He allows Galileo out of jail and allows him to live in house arrest for a while. Then a new Pope comes in charge. He didn't like Galileo. He didn't like Galileo's challenging the church in this way, so he puts him back in jail, and he dies in jail in 1642. But Galileo stood on his principles, challenged the church, and told them, this is the way it is. I can factually prove it. All right, Sir Isaac Newton. Isaac Newton was 26 when he found that all objects are affected by the same force equally. And this is called the law of universal gravitation. The law of universal gravitation, the law of universal gravitation states that everything is pulled by a universal force, and that universal force affects all of those motions that they do. And in this, he said that the same rule applies to all planets, basically backing up the work of Copernicus, Kepler, and Galileo. And people began to believe these statements that were going on, and began to believe these revolutions in astronomy. So Isaac Newton comes up with the universal law of gravitation. Okay, he did not do this by watching an apple fall out of a tree and hitting him in the head. Okay, or an apple falling out of the tree and hitting him in the head. He watched an apple fall out of a tree and finally asked the question, I wonder why that apple fell out of that tree. Most of the questions that Isaac Newton answered, he answered because he was bored. And he began doing scientific testing on it because he was bored. But Newton is the one we give the credit for the law of universal gravitation, and this is a huge impact on the scientific revolution. Breakthroughs in medicine and chemistry. Andreas Vesalius writes his book called On the Fabric of the Human Body. Vesalius tested the boundaries again of the church, because this book is all about the human anatomy. And Vesalius did extensive autopsies and extensive research on the human body. People that had died, he would cut those bodies up, and this was a big no-no during the time, as we've talked about previously. You also had a man by the name of Robert Boyle, who was the man who used the scientific method and applied it to chemistry. You did controlled experiments and came up with Boyle's law of gases. That law that, equal and opposite reactions of gases and pressure and volume and all this other kind of stuff. And so Boyle's law of gases brought to the forefront during the time, and Robert Boyle was the central figure in bringing chemistry to light as a scientific study. Women and the origins of modern science. Again, remember that women did not get the education that men got. So when women were doing this, they had to be really high upper class, as Margaret Cavendish was. She was the Duchess of Newcastle. She was basically a princess. So her doing this was going to be allowed, because people were not going to challenge that level of authority within the world. So she wrote books about human control, about how humans control not only their emotions, their physical bodies, all kinds of different methods of human control and psychological type stuff as well. So she wrote the book on human control. Then you have Maria Winkelmann, who was an astronomer. She kind of had to do her work behind closed doors, because again, this was not really approved of. It was not something that women did, and it was something that men did not teach women how to do. You didn't teach them the sciences. So it kind of was a behind closed doors thing. Maria Winkleman studied astronomy. The gentleman that she studied astronomy under, they became so close that they actually got married. Were married, and then she began to study. But either way, they were very close to each other, and that's why he allowed her to be exposed to this and allowed her to practice in this area, because again, this is not generally accepted by the public or by the church. And then we have to talk about Rene Descartes and Sir Francis Bacon. Rene Descartes is a gentleman who writes On the Discourse of Method. We know Rene Descartes as the father of modern rationalism. He preached about a separation of mind and matter, a separation of mind and body, that the mind could control the body, and that the mind had power over the body, that you could do things with your mind, and that you needed to think in rational thoughts. You needed to think logically. You needed to think in a method, basically. And he began talking about the method of thinking and studying and processing that information. And another philosopher that worked with Rene Descartes, an English statesman. We say that Descartes is the father of modern rationalism, but Francis Bacon worked very closely with Descartes. He was an English statesman and writer, meaning he was of the upper class and he enjoyed writing. But his passion or his hobby was science, and he was very passionate about it. He began to look at different methods of study, looking at the ideas of Descartes and encouraging not only himself but other scientists to think for themselves. Don't rely on what you've seen from the Greeks or the Romans or anybody else before you. Think for yourself, test it, and make sure that it works. And if it doesn't, then say that doesn't work, and test it until you find what does work. Both of these gentlemen came up with an experimental method. The experimental method was the scientific method. The scientific method is a procedure for gathering data and processing it. It begins with a problem or a purpose. That purpose you develop a hypothesis for. If this happens, then this is going to happen. Because of this, this is going to happen. So you come up with the hypothesis, then you test your hypothesis. You have a control, you have a separate system of testing your ideals, but you have a control as well where you don't do the testing on, to show the difference in what happens between the two. And at the end, you take all your data, you analyze it, you draw a conclusion. Yes, I was right on my hypothesis, or no, I was wrong on my hypothesis. And then you do what? You do it again, and again, and again, until you prove your hypothesis is correct. And then you may still even do it again. And these two guys believed that this was the way to do things because anybody could come along and test it. Anybody could come along and say, okay, I want to check and see if you're right. Okay, here's the test I used to do it. Okay, they test it. Sure enough, you're right. Okay, So they wanted the ability to do this. They wanted people to come along and question, and not only question them and their methods, but question all methods and make sure that everything was right. That's how we prove things. That's how we get to laws. That's how we get to from theory to law, so that everything can be proven and is factual and is backed up with evidence and data. Thank you for listening. That's section 1 of your notes, chapter 17. There's a few questions on the last slide. See if you can answer those questions, and have a good evening. We'll see you tomorrow at school.